Hey everybody, welcome to Exodus Lab yet again. Today I'm dealing with this old transformer that I pulled out of a chassis. It's an AWA from 1957 radio, and that's pretty much all I know. When I got it, I was, of course, I've got all these wires hanging out there and I don't know which is which. So I believe that's a fairly common thing for someone beginning with playing with transformers, how to identify the wires. Well, did a bit of research, found a video on YouTube presented by Uncle Doug, and I'll put that link down below. And he goes through the process of identifying the pairs of wires to determine which are the primaries, which are the secondaries, and which most likely are the high tensions and the low voltage, the 5 volt and 6.3 volts. Now, I'm pointing to them because I do know what some of them are, but I'm just bringing you up to date to a point where I got absolutely stuck. And if we just turn our multimeter on, I'll go quickly through the process. I made some assumptions when I looked at them, in that I've got some twisted pairs here, and I thought, well, for the sake of it, I'll check to see whether these are going to be low voltage, 5 volts or 6.3. And searching on the net, I found a guy who put this little list together. So he shows the resistance values of the various wires coming out. So the two primaries should have a rating of 4 to 8 ohms, and this is of course for a 110 volt transformer from the US. The HT, high tension or high voltage wires, they should give a rating of 2 to 400 ohms. The center tap of the HT wires would be half on each wire, whatever that rating is. Say it was 400 for both wires, connect the center tap to one of those HTs and you get roughly 200. And of course works for both of them. The 5 volt and 6.3, they register at less than 1 ohm. So with that in hand and my multimeter, I did some tests, some readings, and I'll just go through them with you. So we'll go to this pair, and as I thought at the time, if I'm right, these will give me a reading of less than 1 ohm. And yes, 0.4 of an ohm, 0.3. So that's definitely low voltage. And our last one here. Again, 0.3, 0.2, 0.3. Yeah. So, which is 5 volt, which is 6.3? Don't know yet, don't know. But we will find out, hopefully, once I apply power to it, and that's really the whole point of this exercise. One of the wires here, the red wire, was connected to the chassis, so to me it's just a simple earth wire. The other twisted pair, I took a guess and said probably going to be the HT lines. And if we take that reading, we end up with 531 ohms. And given that the HT winding is the largest winding in a transformer, that's correct. And while my figures are higher than what's on the chart, it still indicates, hey, that's the largest resistance reading I've got, so these must be the HT lines. Now, it leaves me 4 wires to play with, these 3 yellowish ones and a black wire. So I just, again, took a punt. So I'll leave 1 wire connected to one HT, and I took this to be the center tap. So I should see half the resistance between one HT and the center tap. And I get, 252, which is roughly half of the 500 odd ohms. Connect to the other HT line, and I expect to see the same. It's a bit higher, 280 ohms, but still, again, roughly half. So I'm very confident that I've now identified the centre tap, so that can go away. That leaves these three wires, and this is where I got stuck for a couple of days. The readings that I was getting, well, first off, I'll start again. There's continuity between all three wires. So if I buzz them out using the diode function, I get beeps, whichever combination I choose. So I read further in the article, and I read that when you have three wires with continuity, one of them's going to be a centre tap. And this led me astray, because I've yet to see on any diagram, or schematic should I say, where the primaries have a centre tap. They may, I don't know, but I haven't seen one. Then yesterday I was looking at a schematic, and I noticed a transformer, and it had three wires on it. It had the common, it had 220 volts, and it had 240 volts coming out of it. And suddenly, bang, the light went on above my head, and I thought, this must be it. What I've got is a common and a 220 and a 240. And actually, if I just take the camera around to the common that I'm still playing with, can't see it there, but I can read that I've got a 240 volt and I've got a 230 volt terminal, and of course a common. So that should have alerted me, but I again wasn't thinking about it. So on these three, which must be the primaries, I took some readings, and I'll just call that number 1 and number 2. Number 2, this probe's been difficult. So I get a reading of 16.6 ohms. Now I'm going to just jot that down. So number 1 to number 2 equals 16 ohms. Number 1 to number 3 gives us 14 ohms. I'm just making a note of these. Put that back on number 3. It doesn't want to stay. Just hold on. And this is what I end up doing. Get my pliers onto it and twist it back down and get the hook back down. And if I join up wire 2 and wire 3, I end up with, I'm going to say 2 ohms. So, when I saw the schematic, this all came back to me, and I realised I think I've got the answer. And what I did, this is my reasoning. So if I draw my primary on the transformer, treat that as my common, and I'll assume, sorry, not assume, but that one is 220 volts, and the top one with the greatest winding is 240 volts. So my thinking went in this way: connecting my common to 240 volts will give me 220 volts will give me the second highest reading, which is 14 ohms. If I connect my common over to 240, I'll have the highest reading of 16 ohms. And of course, when I join up the 240 and 220 lines, I will get the smallest reading at 2 ohms. and this is consistent with the windings. So the greatest winding will have the greatest resistance at 16 ohms. The second greatest winding will come out at 220. That'll have a slightly lower resistance value, which in this case is 14 ohms. And of course, if we join up 240 and 220, the distance between the two, or the winding between the two, is minimal. Therefore, that will be 2 ohms. So I've suddenly worked out which is my common, which is my 240, and which is my 220. And I thought, that's it. A bit too simple, but it must be the right answer. So now comes the fun part. I'm going to set up multimeters on all the secondary voltages and apply power to the correct primaries. So I'll be going to the common and the 240 volt. And I'll just set myself up and put some tags on things so that I know what I'm doing. And hopefully this thing's going to work. Well, I've made all the connections, double checked everything to make sure that there's no shorts at all. Just giving it one final inspection. Keep my inquisitive little fingers away from the high or the mains connection. Making sure 240 and common. I've tagged all the leads. As you can see, the 220 is just sitting there idle. Don't need to worry about him. All my multimeters are set to AC voltage, and I've got it all plugged into my variac, which, as you can see, I've also got a multimeter attached to the variac so I can read the voltage output, because I want it to be specific in this case, because first I'm going to bring it up to 10%, and my thoughts are that these two are connected to the 6 and the 5.3, whichever ones they are, and a 10% voltage, which is 24 volts. I should see, say, 0.6 and 0.5 on one of those. And of course the HT, that'll be, well, I don't know where that's going to be, but it's going to be up pretty high. So, turn the power on, and I'll watch. This is exciting. I don't know what's going to happen. I'll be watching the current limiter to make sure it's not glowing, and we'll give it a little squirt, and we're getting readings. That's all positive. So I'll bring her up to, I'm just looking, no smoke, good. Bring it up to 24 volts. Slowly, try and get it right. Sort of all over the place. There we go, 23.8, that's good enough. And 71 volts on the HT lines. And look at that, 0.65, 0.5. So this is 6.3 volts, and that's 5 volts. So that's great. Now we'll just bring it up to full power. So I'm about 100 volts now. Everything's going up as it should. 160, 190, 220, 230, 240 volts. And yeah, 715 volts on the high tension. Connected to a circuit, I believe that will come down. That would be a lot lower with the load on it. And 5.2 volts, which is close enough to 5, and 6.6, which is close enough to 5.3. And everything's looking good. Kill the power. There you have it. I'm surprised. It all worked. I'm glad to see my logic worked out well on the windings. And look, I'm very, very happy with the result. I've never done this before, and yeah, this power up, you saw it live. Haven't checked it before at all. So I hope that helps. Certainly helps me a lot. So I'm now more confident in deciphering the wiring on all other transformers that I've got tucked away in a box. So when the need arises, I now know what to do. At least I can always refer back to this video in case I forget. Well, I hope you got something out of it. I hope you enjoyed it. If so, thanks. And I will catch you soon. Bye for now.